Does everybody have a note sheet? So what we're talking about today is matrices. Matrices. We've talked about matrices before. Now we're going to go a little bit deeper into matrices. We're going to talk a little bit more about them because we briefly talked about them in chapter 1. We're going to talk about them a little more in depth here. Now, matrices. We've covered most of this here. Now, one of the things that's a little bit new, we mentioned it briefly, is an element. Each number inside the matrix is called an element. Now, we call the matrix by capital letters, so capital A, capital B, C, D, so on, and we call the elements the lowercase version of that letter. So here, this is matrix A, capital A. All the elements are going to be defined by lowercase a. And the numbers next to it is the row and column that associates that element with it. So 2, 1 is second row, first column. So first row, second row. First column is -1. Or if we said A3, 2, third row, second column. So third row, second column would be -8. Because we always start in that top left corner, down over rows by columns, give us our dimensions. Dimensions we've covered before. Really the only new piece is elements and defining what an element is. Now let's look at an actual matrix where they didn't give us everything to begin with. Now if we look at matrix A here, if we want to state the dimensions, we're going to define it by the rows. How many rows does this have? 2. How many columns? 3. So this is a 2 by 3. Questions on the dimensions? The dimensions always going to be rows by columns. How many down? How many over? Now, if we want to find A21, element A21, so the first number is the column. So we're in the second column in the first row, which is 9. So element A21 is 9. That's it. Questions on this here? Let's look at the next one. B. Matrix B is given this here. We want to find its dimensions. 3 rows, 2 columns. 3 by 2. Now we want to find the value of element B, 3, 2. So we go to the third row, second column, -1. Yep. Questions? We feel good with this here so far, yes? All right. Now we do have some special matrices, or not so much special, but we gave them a special name. If there's exactly one row, we call it a row matrix. Gotta make sense. There's one row, so it's the row matrix. If there's exactly one column, we call it the column matrix. If the number of rows and number of columns are the same, it's a square matrix. And if every element in the matrix is 0, well, it's a 0 matrix. Now, we do have something called the identity matrix. It's normally denoted as ID, but this matrix here has a diagonal of 1s, and everything else is 0. It doesn't have to be a 3 by 3. It can be any size we want it. It just has to have that diagonal of 1s going from top left to bottom right, and everything else is 0. Is the identity matrix. Questions on this here? Now we will get there. We'll show this here eventually. It's not that important. It's just all we're saying is that this is a 1, and no matter how far out we go, everything else in the rest of that first row, you don't have to write this, is going to be zeros. Yes? Well, below the 1 is going to be 0, and however many rows that we have going down are all going to be 0 following that. Yes? Well, going from top left to bottom right, we know that those are all going to be 1. Essentially, this is just a general way we can say that pretty much all the rest of that 0, dot, 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 it continues in that pattern. But that really doesn't matter. Questions on determining the dimensions and elements? We feel good with this here? All right, addition, subtraction. We've done addition, subtraction before. We did this in the first chapter. Now, the only way we can add or subtract two matrices is if the dimensions are the exact same. So for the first one here, we're going to add matrix B, A and B together. Now, matrix A, they gave it to us in the instructions, is this here. Well, matrix A is A 2 by 2. Matrix B is A 2 by 2. Since the dimensions are the exact same, we can add them together. And whenever we add two matrices with the exact same dimensions, we add the corresponding elements. So 16's corresponding element would be what? -4. 2's corresponding element would be -1. -9 and -3. And 8 and -7. We add the corresponding elements together, the numbers that are in the same spot. And the last thing we need to do is actually add. 16 plus -4 is 12. 2 plus -1 is 1. -9 plus -3 is -12. And 8 plus -7 is 1. That's it. Questions on this here? Do we kind of remember doing these before? A little bit. I mean, it's been a few months. We did these in August. But questions on being able to add these two together? You ready for the next two? So we want to do B minus C. What are the dimensions of B? 2 by 2. Okay. So we have -4, -1, -3, -7. Minus C is almost. Because how many columns or how many rows do we have? 2 by 1. Are the dimensions the same? No. So can we subtract these? No, this is not possible. Not possible. Because we're not able to actually subtract these here. Because for us to add or subtract, the dimensions have to be the same. Any questions on any of this here? We're ready for the next one. All right. So this one here, A plus B plus A. Well, A is a 2 by 2, B is a 2 by 2. We can add these together, yes? Now we can do these in the 30XS, do 16 plus -4 plus 16, and just, because that's what we're going to be doing, adding them one at a time. Or we can actually type these into the calculator. But to type them into the graphing calculator, we need to define the matrix. We need to state what it is. So if you want to grab a graphing calculator, if you don't already have it, you can go on and grab one. Clear all that out. First thing we're going to need to do is pull the matrix up. Second matrix. Second matrix will pull this graphing calculator, or pull the matrix up. And we're going to go over to edit. Second matrix over to edit, because this lets us put the matrices in. Well, luckily they defined them as A and B, yes? So let's put the first one in as A. So the number next to A is already selected, so let's go on and hit enter. First thing again, we need to type are the dimensions. Well, it's a 2 by 2. So we'll say 2 by 2. And our matrix here is 16, 2, -9, 8. Are we able to get those typed in? Question, did you get the matrix? Or did you get it typed in? Okay. Enter. So go on and get it typed in. Once you get it typed in, second quit, second mode. And we're going to do it again, but this time we want to do it at matrix B. Second, I would. So once we get this typed in, second quit, second matrix, over to edit. Now we don't want to retype it in because matrix A we've already set to what we want, yes? So we can press down and go to matrix B. So if you notice the number next to B has been selected, we hit enter. And we do the exact same thing. We'll say 2 by 2. But this time it's going to be -4, -1, -3, -7. So essentially we do the same thing, but this time we type it in matrix B as well, matrix B. We're able to get both in. Second quit. Now we need to recall the matrices. So when we recall the matrix, so we're in a second matrix again, everything in that first list is where we recall it. So the first thing it wanted was our matrix A. So we can just hit enter. Plus, we're adding to it what? Matrix B. So we pull up second matrix. This time we go down to B. And we add to it what? Second matrix A. We're able to get this here. Yeah. So really, for the most part, with addition, subtraction, doing it by hand, doing it in the calculator like this, they end up being about the same length of time. But any questions on how we add or subtract matrices? We feel good with this here? All right. Yes. It quit turning on. All right. Yeah. Go on and grab a different one. It's getting to the point where the batteries are starting to die. Yep. We're ready for the next part. Because I don't think doing more addition and subtraction is going to help us better understand this. I think we got this. Yes? All right. Next thing we're going to look at is scalar multiplication. When we do scalar multiplication, we multiply every element, every number in the matrix by that amount. So here we want to find 5R, which means every element, every number in the matrix CR is going to be multiplied by 5. So we'll say 5 times negative 12. And 5 times 8. And 5 times 6. And we'll also do 5 times negative 16. And 5 times 4. And 5 times 19, because when we scale it, we're making it bigger or smaller. We're just multiplying all those numbers by that amount. Questions on this here? So the first one we can do is 5 times negative 12 is negative 60. Then we do 5 times 8, which is 40. 5 times 6 is 30. Now 5 times negative 16 is negative 80. 5 times 4 is 20. And 5 times 19 is indeed 95. That's it. Yep. We can do these exactly as we did the others in the calculator. Questions on this here? So if we wanted to do this in the calculator, all we got to do is define it first. So we'd go second matrix, over to edit, and hit enter for matrix A, because it doesn't matter since we only have one. And this next one here is a 2 by 4. And then we can type all of these numbers into the calculator. So we say 2 by 4 and then 8, 0, 3, negative 2, negative 1, negative 4, negative 2, 9. And once we get them all typed in, we're going to hit what? Select and quit. Now this one here is asking us to multiply the matrix by what? So the first thing I would type in is negative 4. And then our matrix. So second matrix, we typed it in as A. So we'd have negative 4A. Now the calculator is going to understand that since there's no operation symbol, we didn't put plus, minus, multiplication, division, that they're actually being multiplied. Since they're right next to each other, it's understanding that it's multiplication, telling us that our answer is negative 32, 0, negative 12, 8, 4, 16, 8, negative 36. But again, for the most part, scaling these, the amount of time it takes us to plug them in by hand, we could have just done it, multiplied each one of these numbers by negative 4 and gotten our answer. So it's really not saving us much time, but it does give us the answer. Because if we wanted to, alpha y equals enter, negative 3/7, well, we can say negative 37/8, second matrix A. We can multiply, I mean, I'm just picking a number off the top of my head. Negative 37/8 times A, it'll do it for us. And even if it does give us decimals, math, enter, we'll turn it back to fractions. We feel good about scalars. All right. Well, we're going to put the two together. We're going to use scalars and our addition subtraction. And whenever we use both, negative 4 times B minus 3 times A we apply the scalars first before addition subtraction. We do the scalars and then our addition subtraction. So for this first one here, we're going to have to distribute the negative 4 first. So we'd have negative 4 times negative 4. Negative 4 times 2. And then negative 4 times negative 8. And negative 4 times negative 3. We're going to multiply every number in that first matrices by negative 4. Yes. Ah, thank you. I thought something seemed off. Yep. Thank you. Last thing we need to do is get all the way to the end and realize that the answer's not lining up. Okay. Any other questions on this so far? Now, there's two ways we can do the second matrix. We can multiply it by 3 or negative 3. I normally take the negative with it. Because we can take this here and multiply everything by negative 3. So it'd be negative 3 times negative 9. Negative 3 times 12. Negative 3 times 2. And negative 3 times negative 6. But since we took the 3 and the negative with it, we took both, we're going to be adding the 2 together. If we had just multiplied through by the 3, since we left the negative there, we'd still be subtracting. So either take the 3 and the negative and add the result, or take the 3 and subtract. Now, next thing we're going to do is multiply. Negative 4 times negative 4 is 16. Negative 4 times negative 8 is 32. Negative 4 times 2 is negative 8. Negative 4 times negative 3 is 12. Negative 3 times negative 9 is 27. Negative 3 times 12 is negative 36. Negative 3 times 2 is negative 6. Negative 3 times negative 6 is 18. All right. Last thing we can do before we get to the final answer is we need to add the 2 together. So we'll do 16 plus 27, which is 43. 32 plus negative 36 is negative 4. Negative 8 plus negative 6, negative 14. And 12 plus 18 is 30. We agree with that answer? You're back at A. Yeah. Yeah, if something doesn't come out right, I'd always just look back at your matrices. Yep.
A was 4.
Oh, you flipped them. Questions on how we did this here? Do we want to see how we do this in the calculator? Yeah. So in the calculator, well, the first thing we need to do is go over and edit. Do we want to do the one we just did or the next one? So we're going to plug in A. Now A, our first matrix, is a 3 by 2. So we say negative 5, 3, 6, 2, well, 6. That 2 should be negative 8, 2, 9. second matrix. We'll go to B, which is also a 3 by 2. 12, 5, 5, -4, 4, -7. I think you guys are getting a little bit quicker at being able to type those numbers in. One of the nice things is Enter does make this quicker. Once we get those typed in, this one here is asking for -6b plus 7a. Well, it is nice that we name matrix C A as A and B as B. So what we can do is say -6 second matrix B plus 7 second matrix A, and we have the answer. Because I would say this here with the scalars and addition, subtraction, this is the first one we've really come across in this lesson that it was maybe a little bit faster to type it in than it was to actually work it out. But yeah, questions on this here? All right, now up to this point, pretty much everything we've done so far, scalars, addition, subtraction, except for elements has not been stuff we've covered. Nothing new. We're going to cover something new. And that is multiplication. We did not multiply matrices before. Now, to be able to multiply two matrices, the columns of the first of our dimensions has to match the rows of the second. Columns of the first has to match the rows of the second. If the columns of the first does not match the rows of the second, we cannot multiply them together. It's not possible. And what's interesting is that if it is possible, the rows of the first by columns of the second give us the dimensions of the new matrix. So here, since the columns of the first is R, the rows of the second is R, it says yes, we can multiply the two together. When we multiply them together, the new dimensions is going to be M by T. Okay? Now, the first few here, we're not actually multiplying these two together, we're just seeing if we can. So if we look at A, matrices A's columns is 4. Matrices B's rows is 4. Are these the same? So can we multiply these together? Yes. Now our new dimensions for A and B is going to be the rows of the first by columns of the second. So our new dimensions for this multiplication is going to be a 3 by 2. And that's it. So when we're looking for our new dimensions or our new matrix, it should be one that has 3 rows and 2 columns. Questions on this here? Let's look at B. Can we multiply these two together? No, the columns of the first is 3. Rows of the second is 5. Those are not the same, so no, can't do it. Questions on the first two before we look at the next two? Let's look at 1A. Can we multiply these two together? Columns of the first is 6. Rows of the second is 6. So, yes. Or A times B? 4 by 2. 1B. Can we multiply these together? No. Do not match, so this is a no. Questions on any of this here? All right. You don't have to write this one down. Let's say A so matrix A is a 99 by 1. So it's a single row going down. We have 99 different elements. Matrix B has one row but 99 elements in the column. So those are huge. Yes? Can we multiply these together? Yes. Because our 1 and 1 match. So yes. A times B would be what? So we'd have a 99 by 99 matrix. That thing would be huge. Yes? All right. I'm going to flip it. Let's say B 1 by 99 is being multiplied by A, which is 99 by 1. Can we still multiply them? Yeah. Our column for the first is 99. Rows of the second is 99. So yes, we can multiply them. B times A. What are our new dimensions? We flip it and it turns into a single number. It's a matrix with a number. But that does tell us something important. Because here, even though it does work both ways, A times B and B times A, will they be the same? No. A 99 by 99 is not the same as a 1 by 1. Order matters with multiplication of matrices. Okay. The best way I can describe multiplying two matrices is over and down, over and down, over and down. So when we multiply, I'm going to get the highlighter out. What we're going to do is multiply the first row by the first column. We're going over and down. Top element, next element, next element. And we do it again. First row, second column. If the second one had a third column, we would do first row, third column, first row, fourth column, and we keep going as long as we have that many elements. That's why the columns of the first, how many we have going widthwise, has to match the rows of the second lengthwise, because we're doing this over and down. Now, once we run out, here we've run out of columns in the second, yes? So we move down to our second row and repeat the process. And we get the second one because they match up to our matrices here. Now let's look at an actual example because this kind of does make sense. It sometimes does help if we can put some actual numbers to it. So we're going to do 6, negative 3, negative 10, negative 2, times negative 5, negative 4, 3, 3. So we have a 2 by 2 being multiplied with a 2 by 2. Columns and rows match, so that tells us we can multiply. And the new dimensions are going to be a what? A 2 by 2. So we multiply 2 by 2s together and we get a 2 by 2. Okay. Okay, wrong color. So the first thing we're going to do is over and down. The first number we have is the 6, and it's going to be multiplied by our first number in that column, which is negative 5. Then we will add to it our negative 3 times 3. So in our first row, we've run out of numbers because there's 2 of them, yes? And we multiplied them with their corresponding numbers in the first column of the second. So we've gone through that whole list, yes? All right. Now this time, we do it again, but with the second column. So we'll do 6, times negative 4 plus negative 3 times 3. Now, since we don't have any columns left in the second one, we're finished with the first row's multiplication. At that point, I put the other bracket on it because I know the width of it. It's not going to be any wider than that. We have these two here. Oh, now we're going to move on and do the same thing, but this time with the second row and first column. So I'll have negative 10 times negative 5 plus negative 2 times 3. Second decimal. Now the last one we have to do, over, down, negative 10 times negative 4 plus negative 2 times 3. Now at this point here, we can type each one of these expressions into the calculator. We can do 6 times negative 5 plus negative 3 times 3. Calculator will tell us what it is. So 6 times negative 5 is negative 30. Negative 3 times 3, so it gives us minus 9. I'm going to just go on and do it by hand. 6 times negative 4 is negative 24. Negative 3 times 3 would give us minus 9. Negative 10 times negative 5 is positive 15. Negative 2 times 3 is negative 6. Negative 10 times negative 4 is 40. And negative 2 times 3 is negative 6. Telling us that we have negative 39, negative 33, 44, and 34. I think I messed up one of those numbers last hour, but we agree with this here. Well, I think y'all might have guessed that we can actually do this on the calculator. Questions on this here before we look at it in the calculator? Well, you might have guessed that the first thing we've got to do is actually type it in. The first one is a 2 by 2, so 5, 9, negative 3, negative 2. Second quit, second matrix. Edit. 2 by 2, 2, negative 1, 6, negative 5. Second quit. Now it wanted us to do U, which I labeled as A, times V, which I labeled as B. And we just stick the two matrices next to each other. We do the exact same thing to type them in, put them next to each other because it understands that that's multiplication. This is the answer. Does that make sense? Because I know I went through multiplication kind of quick. But once we have them typed in, we can just retype them out however we want. So the first one's U times V, the second one is V times U, and they do give us different answers because order matters with multiplication. Questions on this here? Yeah. Is here? Okay. Your homework is a worksheet. I'm just going to sit here for later. It's not that bad. You can get that. Work on that later.